So we're going to multiply and divide radicals in this video. We're going to start with dividing. So some properties of radicals is that the square root of a radical divided by the square root of another radical is going to be equal. Actually, I'll write this as a formula. So the square root of a, right, let's say that's some number, divided by the square root of b, a cool property is that this equals the square root of a divided by b. So the quotient of two square roots is just the quotient of a square root of those arguments being divided inside the radical. So writing general formulas is always like more difficult to understand than actually doing examples. So let's do that. Let's do actual examples. So the square root of 80 over the square root of 5, using the formula, right, this is the same as the square root of 80 divided by, the square root of 80 over 5 in a single radical. Okay, in a single radical. So 80 over 5, right, if you're unfamiliar with your 80 over 5 division tables, that's the same as 16. So that's the same as the square root of 16, right, and that's going to be equal to 4. So if you took a calculator, you did the square root of 80, right, that's going to be 8.944, and you took that, you divided it by the square root of 5, right, which is another kind of weird decimal, you're going to get a whole number 4, which is really weird because a square root of 80 and the square root of 5, they're both super long, weird decimals. We could never do this problem without this kind of property of radicals, which is cool. So I'm just going to write it again. This is the square root of 80 over 5, because the square root of 16, right, equals 4. So using these properties is super useful, because if you tried to estimate the square root of 80 and estimate the square root of 5 and then divide them, like, it would just be a mess. So this is an easier way to do that. Okay, so this is a 2 square root 10 over the square root of 20. So now we have a 2 in front, okay, and there's an imaginary 1 in front of the square root of 20. So 2 over 1 is 2. So I'm going to leave that 2 out in front. And this is the same as times the square root of 10 over 20. Okay, so this equals 2 times the square root of 1/2. Okay, 2 times the square root of 1/2. And if we did that in our calculator, that'd give us 1.414. 414. So this is kind of a weird answer. Is there another way that we can make this a bit easier to solve without a calculator? So what we did is root 10, we know we can't simplify that, but root 20 is the same as the square root of 4 times 5. Okay, and if we bring out that 4, it's the same as 2 times the square root of 5. Well, that's odd. So let's try and use this method. This is the same as 2 times the square root of 10, and the square root of 20 is 2 times the square root of 5. Well, notice that these 2's cancel, and we're just left with the square root of 2. Okay, so this is our answer right here. So instead of writing 1.414, blah, 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 after using our calculator, we can simplify the radicals first and then use our property laws, right, on dividing them. So our answer is the square root of 2. If you take the square root of 2 in your calculator, it is in fact 1.414213562, which is the same as when we did it the other method, but this is our exact answer. Okay, so 396. That's a tough one. Okay, so like we did in the last one, let's not do like 1 over 6 times the square root of 396 over 11. Okay, that's not going to be a great way to do it. What we want to do first is we have this big number 396. Let's try and simplify it. So I know that 100 times 4 is 400. Okay, so if we lower this 100 by 1, 99 times 4, that must mean that the 400 is 4 less, so it's going to be 396. So without using my calculator, I know that 99 times 4 is 396. Okay, so this is the same as 99 times 4 over 6 root 11. So this root 11 here, we can't simplify that, we're going to leave it. But what's good is that the square root of 4 is 2, so if we bring this 2 out, it's going to be 2 times the square root of 99 over 6 times the square root of 11. Okay, 2 over 6, that's the same as 1 over 3 times, well, the square root of 99 is, or sorry, we don't know the square root of 99, but if we use our property laws, right, we're kind of done with the 2 over 6. We simplify that to 1 over 3. This is the same as 1 over 3 times the square root of 99 over 11. And we know that the square root of 99 over 11 is equal to, well, 99 over 11 is 9. So 1 over 3 times the square root of 9. Okay, and this equals 1 over 3. The square root of 9 is just 3, so 1 over 3 times 3, and this equals 1. Okay. So we had this weird expression, square root of 396 over 6 root 11, right? That must mean that if we divide them and it equals 1, 396 does equal the same as 6 root 11, because we're taking some number, dividing it by itself. That always gives us 1. So if we have 6 root 11, right, and we wanted to bring this 6 back in, we would have to square it. So this is the same as the square root of 11 times 36. 11 times 36 is 396. So that's why it equals 1. Anytime we divide two numbers and it equals 1, that means that the top and bottom equals each other. So that's just kind of another cool thing to consider. Now let's multiply these radicals without using a calculator. Okay, so, we have a decimal in this first one. That's not always a good start. But I know that 1.6 is equal to 16 over 10, right? Because it's 1.6, like if we have 16 over 10, we can just put like a point in front of each of these. It's 1.6 over 1, right? If we divide the top and bottom by 10. So let's simplify this. 16 over 2 is 8. 10 over 2 is 5. This is as simplified as we can get. So instead of writing 1.6, let's write 8 over 5. So this is the same as, since these are both cube roots, right, we can multiply these. If they were different indexes, like the square root and then a cube root, then we couldn't. So for this one we can. This is the same as the cube root of 5 times 8 over 5, because that's really what 1.6 is. Well, 5 times 8 over 5, see how the 5's cancel? Now we just have the cube root of 8, and remember the cube root of 8 is just 2, because 2 times 2 times 2 is 8. So our answer for this one is 2. Okay, I just talked about how we couldn't use this law if the indexes were different. So there's an imaginary 2 on this square root as the index. This is a square root, this is a cube root. We're not going to be able to multiply these without doing some sort of weird manipulation, so we're going to leave it as it is. Okay, so I'll just write different indexes. Okay, and then the last one here, the fourth root of 24 times the fourth root of 2. So these indexes are the same, they're both 4. That's good. Okay, now we're going to split the 24 up into its factors and hope that there's a fourth root, or a perfect kind of quartic in there. So 24 is the same as 2 times 2, which is 4, times times 6. Well, that's kind of weird because there's no groups of 4 in here. So how's that going to work? Well, maybe if we use our multiplication laws with radicals, we can multiply the 24 and the 2 and hope there's something that comes out of that. Okay, so the fourth root of 24 times 2, right, because those are the insides there, the radicands. This equals the fourth root of 48, right? And I know that 2 to the fourth equals 16. Okay, and 48 is just 16 times 3. So this is the fourth root of 2 to the fourth times 3. The fourth root of 2 to the fourth is 2. So we can bring out a 2, and it's going to be 2 times the fourth root of 3. Okay, so this is your answer for this one. So the radicals indexes were the same. We can use our laws here. Okay, just some more, practical examples of multiplying and dividing radicals.